Okay, bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, we will start with Al-Fatihah. Okay, good. 16 participants join class point. Okay, actually I have activated your you future attendance report. So please, okay, please mark your attendance in the you future. Okay. Okay, good day everyone. Are you ready to start lesson? Are you ready?
Yeah. Ready.
Suara siapa tu? Okay, good. Dah kenal saya? Ada yang belum kenal? Okay, my name is Dr. Suhaila. Okay, you can call me Dr. Su. I will be your lecturers for CS521 Indeterminate structures. So this course actually teach by two lecturers, me as well as Sir Amir. So Sir Amir teach group A, B, C, D. So me myself teach group A, B, C, D, E, F, G, H, and you are from group H, right?
Yes, madam.
Okay. So have you watched the two videos I have uploaded in the YouTube? One for the OBE implementation and another one for the lesson plan. Have you watched that?
Yes.
Okay, good. So how many topics do we have in this course?
3.
3 topics. Okay, so the first topic for this course is called as flexibility method. Okay, flexibility method. So the other two also for analysis of indeterminate structures. Okay, this is the first topic called flexibility methods. Okay, can we start? Are you ready to start? Okay, so for the refreshment, so I want you to answer this. Okay, so go back to the class point just now. You have scanned the QR code, right? Okay, I want you to answer this question. What do you feel to coming back to campus? Okay, we will start right now. So please respond. Okay, boleh slide your phone to the class point and answer the question in the class point apps. Okay, good. Happy. Dah lama dah. Berapa semester dah? 3 semester. Ini semester keempat ODL. So excited. Good. Excited. Any more answer? Nervous pun ada. Okay. Tak apa. Okay. Any more? Excited. Ada yang first time kan? Betul tak? First time nak masuk campus kan? 4 degree. So this is semester 5, means you if you are coming from diploma intake, so this is semester 5 means this is the first time you coming to UITM. Are you coming from matrikulasi or diploma?
Penerapan diploma.
Penerapan diploma means that daripada start last year semester 3, right? So semester 3, semester 4 tu full time ODA, right?
Ya, betul.
Okay, so are you coming back tomorrow Is it tomorrow? You need to coming back?
No, for me, I'm just stay at home for ODL.
Oh, so this semester still at home?
Yes, madam.
Okay, okay. Never mind. Oh, lab also online. Okay. So when should you coming back? Next semester, yeah?
Maybe.
I think so.
So, okay. Okay, any other response? Any other response? Okay, tak apa, kita move to next. Okay, I close this one first. Okay, so actually I have prepared some question for you to participate. Save for review. So we have, okay. So what do you see yourself doing this in this course along this semester? Yang ni saya tak set pun question. Okay. What do you see yourself? How do you see yourself doing in this course along this semester? Anyone to ask? To answer? Anyone to answer? Have you heard something about this course previously? From senior maybe?
Ada.
So what did you hear?
Senior cakap susah.
Senior cakap susah.
Quite challenging but interesting.
Okay, insyaAllah. Most important thing is you need to actually have strong basic from previous courses, especially from solid mechanic. Not all topics, certain topics only, especially beam topic in solid mechanic, as well as some of the topics in previous one, indeterminate structure course. Okay, if you have all these basics, so this course should be better. Okay. Okay, so this is another question for you to participate. I want you to name. Okay, as far as you remember, name of the topic that you have learned in solid mechanic as well as in determinate structure courses. Topic that you have learned previously, whatever topic that you have learned. Okay, can you please name some of them? Okay, beam topic in solid mechanic. Okay, truss topics are in determinate structure. Okay, arch, you have learned arch, torsion as well, portal frame. Okay, about structural system, about internal forces, right? Okay, more circle in solid mechanic. Any more? Any more answer? Okay, any more answer? Okay, buckling of column. Correct, buckling of column. When do you learn this? Last semester. Buckling of column. Ada lagi? What else? Influence line. Displacement, right. Okay, bending moment. Bending moment method ke moment distribution method? Table tu referring to moment distribution method. Sebab dalam moment distribution method tu ada table. Okay. Okay, virtual method, a method to calculate deflection or displacement. Okay. Any more? Any more answer? Ada lagi yang penting you tak mention? Displacement, right? Ada tak internal forces tadi? Okay, internal forces ada. Any more? Okay, you learn something about equilibrium equation. Okay, you use equilibrium equation to determine reaction. Okay, ada reaction kat situ. Okay, method of joint to calculate member forces in truss. Okay, support reaction. So it come from support. Okay, method of section, another method to calculate member forces in truss. Ada lagi? Okay. Okay, that's good. So this one I want to close right now. Alright, paling ramai jawab Ash eh. Okay, so we move to okay, type of determinate structure you have learned previously. Determinate structure you have learned previously, some dia dah jawab tadi kan. Okay, because in previous courses, some of the name of the method is actually come from type of structure itself. Okay, for example, in solid mechanic, beam as the topic, right? And in determinate structures, arch and cable also as topic, frame as topic, truss as topic. Okay, but this time, okay, this time method as topic. So flexibility method as one of the topic, followed by stiffness method. Also method, method as topic, and the last topic in this course is moment distribution method. So all these method will be used to analyze indeterminate structures. Means we need to analyze beam, we need to analyze truss, we need to analyze frame. For each of the topics we will be covered all type of structure, but we don't cover arch and cable. So we just focus on the dominant, okay, dominant type of structure, which are beams, frame, as well as trusses. Okay, because when you understand how we analyze indeterminate beam, frame, and trusses, so we believe that you should be able to analyze arch and cable if you need to do so, maybe in the future. But for this course, we will cover only beam, frame, truss. Okay, as well as composite structure a little bit. Okay. Okay. Okay, we move to the learning outcome. To the learning outcome for this chapter, chapter number 1. Chapter number 1. Okay, so at the end of this chapter, you should be able to, you should be able to calculate degree of indeterminacy, and identify redundant for indeterminate structure. Wait. Kita tak boleh highlight pula. Highlight ni pen ni. Kejap Kejap. I need to close this and open it back. Wait Okay, dah boleh tu. Okay, lambat sikit. Okay, I will share it again Okay. Okay, now can. Okay, so at the end of this chapter, you should be able to, number one, you have to understand the meaning of redundant, redundant, which is actually come from degree of indeterminacy. I believe you have learned how to calculate degree of indeterminacy you learned previously, right? So because when you learn how to calculate reaction in determinate structure, you have actually learned how to determine degree of indeterminacy, and degree of indeterminacy for determinate structure is equivalent to, do you still remember degree of indeterminacy for determinate structure? Determinate structure, what is the value
Equal
of
to
degree of
0.
indeterminacy? Yes, it is equal to 0. It is equal to 0 for determinate structure. So in indeterminate structure, uh, what is the answer for degree of indeterminacy for indeterminate structure?
More than 0.
Okay, it is more than 0. So this is for indeterminate structure. For indeterminate structure, more than 0. Actually the value that you get, okay, whenever you calculate degree of indeterminacy representing redundant in the system, we call it as redundant, because whenever we remove redundant, it will equal back to 0. Okay, so we call it as redundant. For example, if we have, for example, if we have beam, okay, if we have beam, okay, this is cantilever beam, the one that you have learned previously under previous subject, right? Previous course. So when I put another roller here, okay, means that this is equivalent to 1. Okay, equivalent to 1. So the value of 1 is actually representing redundant. And whenever we remove 1 from the system, it will go back to determinate condition. Okay. Number 2, diagrams for primary and redundant structure. So you should be able to draw the diagrams. Okay, you should be able to draw the diagram. So we will have diagrams called primary structure and redundant structure, and most of this diagram is actually determinate structure. Okay, determinate structure. Primary structure. Primary structure is a structure after removing redundant from the system. Redundant is to remove from the system. We will determine we will analyze the primary structure, and then we also have redundant structure, which is also determinate structure. So all analysis actually in this topic, we will analyze all reaction, all internal forces and displacement in determinate structure. That is why you need to have the strong basic in analysis of reaction, internal forces as well as displacement. The three things that you have learned previously. Okay, and then calculate displacement. Okay, as I mentioned just now, displacement. And finally, after redundant has been determined, then we will determine reaction in the system. Reaction. Remaining reactions means 3. Remaining reactions means 3. Because 3, in determinate structure, we calculate reaction 3 unknown reaction, because determinate structure we have 3 unknown reaction, and these 3 unknown reaction can be determined using 3 equilibrium equation. Okay, 3 unknown reaction can be determined using 3 equilibrium equation. However, in indeterminate structure, we have more than 3 reactions. Okay, for beam and frame, we will have more than 3 unknown reaction, and these unknown reaction, not 3, more than 3. Okay, this unknown reaction cannot be determined using equilibrium equation, because the number of unknown reaction more than 3. Okay, that is where flexibility method takes place. Okay, if you have question, you may ask. Okay, so you have learned how to analyze, for example, beam. For example, Okay, you have actually learned how to analyze reaction for beam, frame, and truss, and then you have also learned how to calculate internal forces in beam, frame, as well as truss, and then displacement. I believe you have learned how to calculate displacement in the last course last semester. Okay, so we go directly to introduction. So in structural engineering, the flexibility method is actually the classical consistent deformation method for computing member forces and displacement in structural system. Actually, as I said just now, so this is in simple word. Okay, in simple word, when I need to consider flexibility method is actually when we cannot determine, okay, when we cannot determine reaction directly. Okay, because we can only determine reaction whenever number of unknown reaction is equivalent to number of equilibrium equation, means 3 and 3. When we have more than 3 unknown reaction, we cannot determine the reaction directly, and that is where the flexibility method takes place. Okay, so just remember that we are actually calculating the unknown reaction using we are actually calculating the redundant using flexibility method, and after redundant has been determined, then we can solve the remaining reaction. Okay, so in modern version formulated in terms of member forces. Okay, in terms of the members flexibility matrices. So redundant, the redundant in the structure for the limit for the redundant can be analyzed using manual calculation. Means that for this topic, we can be able to analyze structures whenever redundant is up to 3 redundant only. 3 redundant only, because if we have more than 3 redundants, we cannot calculate using calculator or using manual calculation anymore. So we have to have another topic, because the limitation for flexibility method, okay, is only 3 redundant. Okay, 3 redundant. Basically, what we will do is we will solve for the redundant using equilibrium equation. Okay, using equilibrium equation. So we may have analysis of indeterminate structure with one redundant, where we will solve the redundant using one equation. If or we can have two redundants where we can solve using two equation, means two simultaneous equation, or we can also solve the redundant, the three redundant using three simultaneous equation. Simultaneous equation means we can use calculator to solve for the value x, y, and z. Okay. Okay, so a structure of any type is classified as statically indeterminate. So this is the simple definition. When you want to determine whether the beam or frame, the beam and frame or the structure, okay, can be classified as indeterminate whenever number of unknown reaction or internal forces exceed number of equilibrium equation. So actually, okay, so actually for beam and frame, it is just finding the difference between unknown reaction and equilibrium equation for beam and frame. But to calculate degree of indeterminacy for truss, you need to consider the member forces as well. That is why when you learn previously, when you calculate degree of indeterminacy, for the formula to calculate the degree of indeterminacy for truss, okay, it is m plus r minus 2j. Do you remember? M plus r minus 2j. Okay, this is actually the formula to calculate degree of indeterminacy for truss. Okay, for truss we use this formula. But for beam and frame, it is just easy because we just have to identify number of unknown reaction and compare with number of equilibrium equation. So for example, if we have 4 unknown reaction, we just minus 3, so we get 1. So 1 is actually redundant in the system. Okay. Okay, so we move to this. Okay, as I mentioned just now, this is not the only topic. So this is one of the technique actually to calculate or analyze indeterminate structure, and flexibility method will take place whenever we cannot determine the reaction directly using equilibrium equation because number of unknown reaction uh, is more than 3. Okay, more than 3. If we if we want to calculate the reaction or internal forces in frame, we need to consider the internal forces as well by using the formula I showed to you just now, m plus r minus 2j. Okay, so this method is also known as force method. This method is also known as force method, and if you have the textbook, if you have the e-book for this course, Hibler textbook, RC Hibler, the writer, RC Hibler, structural analysis by Thomson, the distributor for this book. Okay, if you have, and any other book, maybe you cannot find the topic name flexibility method because it has another name. Okay, it is also called as force method. Okay, force method. So, flexibility method actually involve removing restraint, enough restraint. Removing enough restraint means removing redundant, because redundant is the restraint in the structure, in indeterminate structure. Okay, so we identify redundant because we need to we will remove redundant in order to analyze the reaction. Okay, what we need to do, first thing that we need to do is to analyze or determine value of redundant, because redundant is actually the problem in, okay, in flexibility method when we have, for example, 4 unknown reaction. So one, if redundant value is determined, then we can be able to solve remaining reaction using equilibrium equation. So the problem now is the redundant. So it is called as restraint in the system. So so that we have to calculate the redundant value. So how to calculate the redundant value is by analyze determinate structure, which we will have primary system and redundant system using all that you have learned previously, including reaction, internal forces, moment equation, as well as calculate the member forces in truss using method of joint virtually. And then you have to apply also the one that you have learned previously in order to calculate displacement, which is virtual work method. So all these you must apply into the analysis in order to calculate the redundant. So once the redundant is determined, then we should be able to calculate remaining reaction using equilibrium equation as usual. Okay, so but whenever you want to calculate redundant, so redundant is to remove from the system. Whenever we want to calculate redundant is actually we need to remove from the system. And when we remove redundant from the system, we should make sure that, okay, the after removing redundant, the structure is statically determinate and stable. Statically determinate and stable. Okay. Okay, this is just a quick review. The idealized beam, the one that you always get in analysis. Okay, and the actual position, the actual picture of beam with This one is called as simply supported, right? Where we have pin and roller. Okay, so this is another support connection in real situation that we need to understand. So number one tu typical pin supported connection. Okay, this is how the original one look like. Okay, we also have fixed supported connection. Okay, roller connection. This is the roller connection. Okay, this is roller connection, as and the last one is fixed supported. So in real situation, so later on when you as engineer, so you go to site, okay, there you will meet all this real support condition. And of course, because reaction is actually come from support, yeah, reaction come from support. Okay, so actually you have learned determinate structure previously, and how unstable structure look like, and this is indeterminate structure. Okay, so I want to ask your understanding. So in your own word, in your understanding, okay, what is actually the difference between these two terms? Okay, the difference between determinate structure and indeterminate structure. Okay, relate back to what you have learned previously and today. Okay, and today, indeterminate structure and determinate structure. Okay, please try to respond to this question. Ni yang before this kejap Restart again. Okay, so what is the difference in your own word, in your understanding, based on your understanding, the difference between between determinate structure and indeterminate structure? Okay, so we calculate, we can define the structure based on degree of indeterminacy. Okay, degree of indeterminacy, degree of freedom. Okay, degree of freedom, we will look at it in detail in chapter, in the next chapter. Okay, okay, other than this. Okay, equilibrium equation. When we cannot calculate reaction using equilibrium equation, means that we need to consider using flexibility method. Okay, so because in static equilibrium, we only we have set the limitation. The limitation is up to 3. So other than 3, we cannot solve using equilibrium equation. So that is why, as I said, flexibility method comes in. Okay, ada lagi? Any other answer? Difference between determinate structure and indeterminate structure. Okay, load distribution. Okay, anything relate with the support condition? Do you have any idea? Of course, bending moment and shear force will be different. In terms of displacement maybe, or in terms of support? Any more answer? Yes, stability as well. Okay, type of support give effect of number of redundant. Yes, correct. Any more answer? What do you understand about determinate structure? Any more answer? Any other answer? Regarding displacement, do you think the displacement for determinate and determinate structure and indeterminate structure will be same or different? Or which one is good actually? Which one has advantages compared to the others? Any more? Any other answer? No one. Okay. Okay, we close this first. Okay, actually, quite of lot of difference between determinate structure and indeterminate structure, especially due to the support condition, due to the displacement, due to the strength of the structure. So there's so many. Okay, so we move to next one. Okay, statically determinate and indeterminate structure. So this could be the difference. Okay, where determinate structure, we can use static to determine reaction and internal forces. Okay, static equilibrium. So the one that we have actually used start from solid mechanic or start from static dynamic. Static kan, static you have learned in the first semester, right? So whenever we want to analyze all the structure, actually we have uh, apply static equilibrium where because we have also dynamic condition. So static are the limitation that we need to follow. For example, three equilibrium equation static. So Hooke's law, remember Hooke's law, the one that you have learned maybe in diploma kan, you have done the experiments to see the shape, okay, under tensile test if I'm not mistaken. Okay, then you get the graph, force versus deflection, force or we call stress strain curve tu. Okay, so determinate structure we can use static referring to three equilibrium equation to determine reaction. Means that we can calculate reaction, we can calculate internal forces in determinate structure using three equilibrium equation, but we cannot do that for indeterminate structure. Okay, means that we have to have another equation in order to solve for the reaction. Okay, this is one of the reason. Okay, one of the different. Okay, to analyze an indeterminate structure, additional equation, okay, need to be consider. Okay, another equation, because equilibrium equation only cannot be used to identify all the reactions. So we need to have another equation. Okay, another equation. And this equation considering with actually comes with the geometry of the deflected shape. Okay, we will have another equation which is called as a compatibility equation, and compatibility equation is actually come from deflected shape of the structure. Okay, of the structure. So this is actually the additional equation that I mentioned just now. Okay, so benefit of indeterminacy or benefit of indeterminate structure compared to determinate structure. Number one, okay, of course, there are many more. This is only some of advantages. Okay, number one, indeterminate structure are stiffer than determinate structure. Okay, do you understand the word stiffer, the word stiff? Do you understand the word stiff? Stiffer than determinate structure. Okay, do you understand the word stiff, the word flexible? Stiff versus flexible. Understand, right? Okay, so can you imagine this statement represent to indeterminate structures and determinate structure? The indeterminate structure are stiffer than determinate structure. So what happen if the structure is stiffer than the other one? Okay. Another benefit. In indeterminate structure have a lighter and more rigid structure. Okay, rigid structure with the added of redundancy in the structural system. Added of redundancy means that it may be come from support. Okay, because we calculate degree of indeterminacy based on the support condition. Based on the support condition. Okay, and in trust also we have to consider as well the member forces. Okay, and other reason is increase in the overall factor of safety when we have indeterminate structure. Okay, so I hope you understand the okay, that the indeterminate structure in terms of rigidity. Okay, in terms of rigidity, it is more rigid compared to determinate structure. So when it relates to rigidity or the stiffness, okay, from these two diagrams, so look at the diagram, we have diagram A and diagram B. We have diagram A and diagram B. Okay, A is actually a simply supported beam. A is actually a simply supported beam where we have pin at A and roller at B. And diagram B is actually B. Okay, diagram B is actually a continuous beam. A continuous beam where we have another support. Okay, additional support. So we have a roller. There are two roller compared to the previous one, diagram A. So from the diagram, which one got lesser displacement value? Okay, which one got lesser displacement value? Okay, which one? Okay, which one got lesser displacement value? Diagram A is determinate beam, diagram B is indeterminate beam. So what do you think in terms of displacement? Which diagram got lesser displacement? Okay. Okay, so okay, so it should be B, it should be B. So indeterminate structure will have less displacement compared to determinate structure. Okay. Okay, so we move to okay, of course, you have to understand the support characteristic because reaction actually come from support condition. Okay, and in order to remove redundant later on, when we analyze the structure, removing redundant uh, means change the support condition. Removing redundant means change support condition. So you need to understand the concept of support where pin has two unknown reaction X and Y. So if we want to remove one redundant or one reaction from pin, so we should be removed. Can we just remove anyone that we like, or we should remove AX, okay, rather than remove AY. So the concept must be clear. For example, if we have pin support, fixed support XY fixed support, we have moment at A, for example, and yang ni moment at A, AY and AX. So if we want to remove one redundant, so which one should we remove first? Can we simply remove from fixed support? Can we simply remove AY or cannot? Okay, so we have to understand the support characteristic before we identify redundant. Okay, because remember redundant is to remove from the system. Okay, so now in flexibility method, actually we need to satisfy what we call principle, or actually it is equation, okay, or relationship. Okay, what we need to understand that in order to analyze structures using flexibility method, number one, we need to satisfy number one what we call as equilibrium. Okay, equilibrium, okay, equation. Okay, the one that you have learned previously, equilibrium equation, means that we will apply equilibrium equation in order to analyze, okay, the reaction later on. Okay, condition number two that we really need to consider is actually the one that I have said just now. It is called as compatibility. 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 It is called as compatibility. Okay, compatibility. And the third one is actually force displacement relationship, force displacement effect. Okay, number one is equilibrium equation. Number two is compatibility. Okay, compatibility equation. Okay, this is number two. Okay, number one, equilibrium equation as usual. Okay, when we have to apply total moment, total Fy, total Fx, and then we have to have compatibility, and compatibility relates with geometry of deflected shape of the structure. Okay, compatibility, and the third one is actually force displacement. Number three is force displacement. Okay, force displacement. We can also call it as equation. We can also call it as relation. Okay, force displacement. Equilibrium equation, compatibility, as I mentioned, compatibility relate with displacement. It relate with displacement geometry for the structure. Okay, and last one is force displacement equation or force displacement relation. So these three principle, okay, should be fulfilled whenever we analyze the structure or indeterminate structure using flexibility method. Actually, you have actually meet two of this. Okay, 1 and 3, you have actually meet them. Okay, this one and this one. Force displacement. Compatibility is new for you. Force displacement, you have actually meet this. Okay, when? Force displacement ni. Force displacement. Can you recall it back under the previous course? Whenever you want to calculate displacement, you need to apply a unit force. Remember? Do you remember?
One unit force
Under
ke?
unit, a unit force. Okay, under topic of deflection. Okay, what is the name of the topic of deflection that you have learned in the last course? Topik
Virtual
apa yang
work.
you dah? Virtual work. Yes, virtual work. So virtual work tu in virtual work method you are analyzing what? Is it deflection or displacement?
Displacement.
Displacement. So displacement you will apply what? In order to determine the displacement, you have the virtual system and you apply a unit. A unit?
1 unit load. 1 kilonewton.
A unit load, a unit force. A unit force means that, okay, whenever you want to calculate deflection delta, you will apply a unit force. A unit force in the virtual system. Betul tak ni? Betul tak?
Betul.
What if you want to calculate rotation? What if you want to calculate rotation? Rotation.
1 unit moment.
Okay, unit moment. Okay, so this is actually, this is displacement, delta and rotation are displacement. Okay, and P as well as M, okay, these two are forces, isn't it? Betul kan?
Betul.
So means that you have actually learned about the force displacement equation or relationship, okay, in last semester. So P, a unit value of P, okay, this is actually force. Maybe this is a horizontal force or vertical force. Okay, whenever you want to calculate deflection, okay, and you will apply moment whenever you want to calculate rotation. Okay, so this is actually force displacement, okay, relation. Okay, so the new things that you need to understand in flexibility method is compatibility equation. Compatibility equation. And compatibility equation relates with the displacement geometry. Displacement geometry, it will relate with displacement, okay, in order to have the equation to solve for the redundant. Okay, so next, any question you want me to break for a while, maybe for 5 minutes, or you want me to continue?
Continue.
Continue, okay, so continue, yeah. Okay, of course, there are general procedure, but I don't want you to actually remember the steps. Okay, remember the step because there are so many things to remember. If you are trying to remember the steps, so there will be so many things. Okay, so many things because this is the topic where everything that you have learned previously, okay, analysis of reaction for beam, frame, truss. Lepas tu apa, internal forces. Internal forces ni ada moment equation. And then ada method of joint. Okay, and then frame analysis, shear force diagram, many moment diagram. There's so many things. So what I want you to do is to set your aim. To set your aim. Means that, okay, you have to look at your final goal, final aim. So the final aim for this is actually number 7 and 8. Means that anything that we do, we are actually, okay, we do for reason. Okay, we do for reasons. Why I need to do this step? So this is for this. Why I need to do this step? This is for this. So you must have the answer for everything that you do. So set our aim first. Okay, set our aim first. Okay, our aim, number 1, flexibility method is one of the method to analyze reaction. Okay, you have to understand that flexibility method takes place whenever we cannot solve reaction using equilibrium equation because number of unknown reaction exceed equilibrium equation, 3 equilibrium equation. So number 8 ni, if you see number 8, the final one, number 8. So number 8 ni calculate remaining reaction means 3 remaining reaction. This is 3 remaining reaction. 3 remaining reaction. So 3 remaining reaction, if we have the value of redundant from previous step, can we determine remaining reaction? Can we?
Can.
Okay, using what? Using?
Equilibrium equation.
Yes, using equilibrium equation. Okay, but before we can calculate 3 reaction from, okay, from total reaction in indeterminate structure, we should be able to solve or to determine the redundant forces first. Okay, so this is, okay, this is actually the problem. Okay, this is actually the problem. Okay, so we should understand that, okay, we have our aim. We have our goal. Okay, and in order to achieve our aim, of course, there will be a problem. Okay, or many problem, or one problem, or two problem. Okay, so we have our aim. So our aim is to analyze or calculate remaining reaction. Remaining reaction is 3. Okay, so before we can determine these 3 remaining reaction using equilibrium equation, we have to determine redundant first. So now redundant is the problem. Redundant is the problem. So what we need to do is to determine redundant. So how to determine redundant? How to determine redundant? How to determine redundant? You nampak tak arrow tu?
Using compatibility equation.
Yes, we will solve the redundant using compatibility equation. Okay? This is the only way to calculate redundant. We calculate redundant or we solve redundant using compatibility equation. And compatibility equation comes from displacement. The compatibility equation comes from displacement. Nampak tak atas tu? Displacement means that to have the equation, to have the compatibility equation, we should calculate displacement first. Displacement for each structure. Displacement, okay, displacement for all determinate structure. So in step number 5, we actually have several. Not many lah. We have primary structure, we have redundant structure. And redundant structure will be depend on the redundant number. If we have one redundant, we have one redundant structure. If we have two redundants, we have two redundant structures. If we have three redundants, we have three redundant structures. Okay, so maximum as I mentioned, we limit up to 3 redundant, right? So if we go for maximum, we have 3 redundant plus 1 primary structure. So total is 4. Means that we have to calculate displacement for the determinate structures. How many structures? Primary structures plus redundant structures. And primary structures and redundant structures are all determinate structure. Means that we have to apply what have we learned. You learned in previous subject. You have learned how to write determine reaction as well as internal forces. And you have learned how to calculate displacement using method of virtual work just now kan. Method of virtual work. So we need to do all this, okay, in the previous step. Okay, calculate displacement. Before we can calculate displacement, of course, we have to have all this system, primary structure and redundant structure ni. Okay, all this is actually determinate structure. Determinate structure and indeterminate structure, we have to do 1, 2, 3. Okay, can you recall back or give summary from previous courses that you have learned in simple word? And actually you have done this from diploma as well. In structural analysis, what are the output actually? In structural analysis, what are the output? Loading is input. Support is input. Okay. Material is input. Output. In structural analysis, there are 3 types of output. And this output, if you, for example, model the structure using software, you put all the inputs, you draw the model, you put all the input, and then you run the model, you will get outputs. So what are the 3 output you get from analysis? What are the 3 output?
Internal force.
Okay, internal forces, number 2, output number 2. Internal forces is actually output number 2. This is internal force. Internal forces. This is number 2.
Support reaction.
Support reaction. So number 1 should be support reaction. Support reaction. Okay, number 2 is internal forces. Number 3. Siapa tahu number 3?
Displacement.
Displacement. Displacement. So actually whatever you learn, start from you learn static and then solid mechanic and then determinate structure and then indeterminate structure, you are actually determining 3 types of output. Okay, number 1 is called as reaction, support reactions. Number 2 is internal forces. Internal forces. So in beam and frame, what type of internal forces that you have learned? Internal forces in beam, for example. Internal forces in beam. Under beam topic in solid mechanic, what have you learned? After you learn how to calculate reaction, and then what have you learned? You remember? Ingat tak? In solid mechanic, under beam topic, you learn how to calculate reaction using equilibrium equation, followed by under the same topic.
Shear force. Shear force.
Yes, shear force. Another one,
Bending moment.
bending moment. Bending moment. Shear force and bending moment are actually internal forces. Shear force and bending moment are actually internal forces in beams and frames. Okay, and in order to do that, you start with writing the equation, right? Writing the equation. Have you remember how to write the moment equation for beam and frames? Have you remember? Okay. But we only focus on the moment equation, yeah, in flexibility method. The moment equation. Moment equation. So make sure you need to do some revision about writing the moment equation for beam and frame. Okay, for determinate structure. Okay, internal forces in truss. Internal forces in truss. We call it as, who remember? In truss. You did using method of joint, method of section, do you remember?
Yes. Yes.
So what is it called? It is internal forces in trusses. You call it as what?
Compressed tension.
Compression tension is for the sign. Okay, for the sign. So it is actually member forces. Member forces. Or yes, member forces in truss. Okay, is actually internal forces. Or sometimes we also call it as axial forces for the truss, right? Okay, so internal forces. Okay. Next output is displacement. Displacement. Next output is displacement. Okay, in order to calculate displacement, what information that you need in order to calculate displacement? When you calculate displacement, you need what? Do you need internal force?
No.
No ke yes? Displacement. The formula to calculate displacement itself, for example, the formula to calculate for truss, n small n and capital N. N is stand for
Axial force.
axial force or member force. Means that whenever you want to calculate displacement, you need to have internal forces, right?
Yes.
Okay, so to have internal forces, do you need to have support reaction first?
Yes.
Okay, so nampak tak? So yang you belajar tu, dia ada step-step dia kan. Start learn about reaction. So next after that, you calculate how to determine internal forces. Internal forces or writing moment equation. So how do you write the moment equation? After having reaction, right? Without reaction, we cannot write the moment equation for certain types of structure. Okay, so means that, so whatever we do, there must be a reason. So why I need to calculate deflection? What is the formula to calculate deflection? In the formula itself, ada member forces kat situ, ada internal forces kat situ dekat N tu. N is actually member forces from two system. One is real system, one is virtual system. N is actually member forces or internal forces. And can we have internal forces without having reaction? Cannot. We have to have reaction. Of course, there's some little, okay, little bit, maybe some. There may be some of question that we don't need to have the reaction first, but almost okay. Structures we have to have the reaction first. So the step start from reaction followed by internal forces followed by displacement. Okay, so the diagram, the primary structures and redundant structures in flexibility method, we should, number one, calculate reaction, number two, internal forces, and then we should calculate displacement. Because this displacement, from displacement, we will write the equation. We will write the compatibility equation. Displacement that we get from from primary structure and redundant structure, we will use in the compatibility equation. Okay, then dah dapat compatibility equation, we just solve for the redundant. So basically, whenever student have problem with flexibility method is because of this. Yang mana satu? Because of this, right? Do you realize that? Okay. Okay, so do you understand what I'm trying to say to you? Do you understand? So I want to tell you that most of the problem of the students in flexibility method is when the student cannot do all this analysis yang ni, yang dalam box ni. This is the main problem. This is the main problem. If you can calculate reaction, calculate member forces in truss. Member forces in truss, you cannot calculate using method of join one by one step like what you have done under truss topic. Because at that time, okay, at that time you have to understand that in this subject, in this course, we use knowledge that you have learned previously. So what most important is the value, not the method you use to calculate member forces. Kan, contoh trust kan, trust. Previously under trust topic, you learn there are two methods to calculate member forces. The method is using method of join and method of section. Okay, these two are the methods to calculate member forces. Because at that time you are what we call, okay, we measure your attainment based on your understanding, calculating the member forces, the internal forces. But this time, because at that time the output, the outcome at that time, bila you topic trust, what is the learning outcome? Students should be able to calculate member forces using method of section. Betul tak? Yang tu outcome dia. Betul tak?
Betul.
Kan? So you kena boleh differentiate benda ni. Okay, so bila you belajar topik tu, nama dia topik trust. Apa dia learning outcome for trust topic tu? Learning outcome dia, student should be able to calculate reaction using equilibrium equation. Yang tu is the attainment that student should have at the end of the topic. Lepas tu, learning outcome for trust. Student should be able to analyze member forces or internal forces in the truss using method of section, method of join. Jadi your attainment tu will be based on your ability to use method of join and method of section to calculate internal forces. But remember, for flexibility method, that is not the aim. Okay, that is why I say you have to have the aim. You have to understand flexibility method. What is your aim actually? So at the end of this topic, what is the attainment that you should get? So the attainment is you should be able to determine redundant. So doesn't matter whatever method that you use in order to determine the internal forces. Do you get the idea? Means that kalau you masih nak buat contoh kalau you masih nak calculate member forces using method of join or method of section, you akan take some time buat benda tu. But what most important is the value, because the value tu yang kita nak untuk letak dalam formula. Do you get what I mean? So some of the students, bila they having problem dengan flexibility method, dia ada problem dengan the basic concept. But if you have all the basics, so this one should be easier. Okay, means that at this time, bila you masuk indeterminate structure, the internal forces in Truss, you should be able to determine the member forces using easy method. Easy method of course dia bukan satu standard method, name of the method, tapi ada satu teknik yang we call as easy method, so that using that method you can get the member forces easily. Within 2 or 3 minutes you can have all the member forces. Okay? So that is the idea, that is the concept. Sama juga macam moment equation. Moment equation. Moment equation, in order to solve displacement, so displacement for beam kan, kita akan integrate like this, integrate moment equation. Integrate two moment equation. So yang ni I just take the formula directly first. Okay, this is actually the formula to calculate displacement in beam and frame. In beam and frame. Moment equation, two moment equation. So moment equation sama juga masa belajar beam, moment equation tu is your learning outcome. Learning outcome maksudnya masa belajar beam, memang learning outcome dia students should be able to write moment equation. You get what I mean? You get what I mean?
Yes, madam.
Okay, but in this course, learning moment equation tu is not the outcome. Okay, means that you don't need actually to show to the final moment equation, because the final moment equation, that final moment equation you need to substitute into the formula of displacement. So we want the moment equation because we want to have the displacement, because displacement is needed in order to fill in the compatibility equation, and after that we can solve the redundant. So you have to understand so this general procedure, so step by step. Okay, so bear in your mind. So objektif kita apa? Objektif kita to calculate reaction. So what is the problem? The problem is redundant. So how to determine redundant using compatibility equation? What is inside the compatibility equation? It is all displacement in system, primary system and redundant system. What we need to do in all this system? We will calculate reaction, we will calculate the internal forces in order to substitute into the displacement formula. Okay, so every procedure ni there are reason. Okay, that is why what you need to do is actually understand what is your aim. So means that the learning outcome, aim, and then go backward. Okay, tengok step number 8. Why I have to have remaining reaction? Because there are 4 unknown reaction. I want to solve 4 unknown reaction. 4 cannot be calculate using equilibrium equation. So I have to apply to apply flexibility method. One redundant can be determined using compatibility equation. How to solve compatibility equation? By having displacement in systems, indeterminate system called primary system and redundant system. So how we write the compatibility equation based on what we call as principle of superposition. Dekat sini ada apply principle of superposition. Okay, principle of superposition. Okay, in order to write the principle of superposition or the equation, which is come from principle of superposition, we should determine or choose redundant first. Choose redundant. So how we get redundant? We get from degree of indeterminacy. Okay, faham tak konsep flexibility method? Okay, faham tak konsep flexibility method? Ada yang nak bagi idea? Or nak cakap kat mana tak faham? Konsep dulu. Because once you understand concept, nanti kita nak apply to all type of structure. So I will deliver to you the derivation of compatibility equation for beam with 1 redundant and 2 redundant. And that's all. Because whenever you have understand the concept, understand the meaning of flexibility method, and this procedure can be actually applied to all type of structure, including beam, including frame, including trusses, including arch, including cable, including all type of indeterminate structure. Whenever we understand the principle of actually the flexibility method. Okay, do you have any question regarding this, all this procedure?
Tak ada. Saya rasa kena buat soalan baru nampak jelas kot.
Okay, so I want you to understand the concept first. Because concept ni kita akan apply. Kita akan apply to all. So nanti bila you buat soalan, you kena remember what I actually told you just now. All this principle, all this procedure. Sebab kalau ramai student yang dia tak faham prosedur, dia tak faham konsep, dia hafal prosedur. Bila hafal prosedur, there's so many things, belum masuk effect. Nanti kita ada effect temperature changes, kita ada effect support settlement, kita ada effect fabrication error. Kalau you don't really understand the concept, okay, the meaning, nanti kan you semua benda yang saya sebut tadi tu, you akan hafal satu demi satu. But kalau you faham the concept, semua tu dia group tau. So once you understand the concept, you can be able to solve any question. Okay, regardless any effect, any type of structure, you should be able to answer. Okay, so kita move to, of course in the first class ni memang saya akan fokus on concept dulu. Saya tak akan buat full example pun. Nanti full example saya akan buat satu video untuk one example. So that nanti you watch the video and then we will do maybe example in the next class. Okay, so yang ni principle of superposition, the idea of principle of superposition. Because principle of superposition ni kita tak apply only in flexibility method. Principle of superposition ni is actually one of the principle yang very common in engineering. Principle of superposition. We will apply principle of superposition also in chapter 3, not only in this chapter. Okay, the idea is when we have indeterminate structure, we have to pisahkan. Okay, to divide the structure into determinate structure. Okay, it may be 2, it may be 3, it may be 4. Okay, and in order to apply principle of superposition, as usual, in static equilibrium condition, we have all these principle. Okay, the material must behave in linear elastic manner so that Hooke's law is valid. Benda ni dah belajar awal-awal dulu. Okay, the geometry of structure must not undergo significant change when the load are applied. Okay, a small displacement theory applies. So this is all the principles. I don't want to elaborate more. Dekat sini tak yalah kita move to this. Okay, so move back to the concept. What is actually flexibility method? Flexibility method apa dia? When we have flexibility method, what is flexibility method? Siapa boleh try to answer? Flexibility method. In your own word, apa yang you faham flexibility method? Tadi saya dah explain tadi, 1 jam setengah. Flexibility method. In your own word. Ada siapa-siapa nak jawab?
Force method.
Ya?
Force method.
Force method. Okay, itu nama lain dia. Okay, force method, another name of flexibility method. Apa yang you faham about flexibility method? Flexibility method. Apa yang you faham? Lagi? Apa yang you faham on flexibility method? Tadi saya dah ulang banyak kali. What is flexibility method? When to apply? Why we apply? When to apply flexibility method?
Untuk removekan redundant.
Okay. Acceptable. Lagi? Ada lagi? Why we apply? Why we apply flexibility method? Yang tadi when to apply. Kita apply flexibility method bila kita nak solve redundant. Okay, why we apply flexibility method? Why we apply? Why? Why we apply? In your own word. I want to hear in your own word. Why we need to apply flexibility method? Why don't we just use equilibrium equation? Why we need to apply flexibility method?
Jadikan dia determinate.
Okay, nak jadikan dia determinate means that removing redundant. Okay, kenapa kita nak pakai flexibility method is whenever we cannot determine reaction directly using equilibrium equation. Boleh tak you ingat yang tu? Boleh tak you ingat yang tu?
Boleh.
Okay, when we have, for example, this. Okay, 1, 2, 3, 4. Okay, degree of indeterminacy is equal to 1. Because we have 4 unknown reaction and only 3 can be solved using equilibrium equation. So redundant is 1. Redundant is 1. So what we need to do with redundant? We want to remove. Remove redundant, remove restraint. Means that after we remove restraint, we will have determinate beam. Nampak tak? Remove restraint, we get determinate beam. Remove roller, we get cantilever beam. Do you get the idea? Tadi ada roller kan? Ada roller sini. Ada roller. So dekat roller tu ada reaction, right? Reaction. Remove enough restraint means remove one of the reaction. Okay, remove one of the reaction. So remove BY. So when we remove BY, it become cantilever beam. Is this determinate beam? Is this determinate beam? Is this determinate beam?
Yes.
Asal macam ni kan? Asal macam ni. Ada 4 unknown reaction. 4 unknown reaction. Remove this, it become cantilever. Can we remove another? Okay, can we remove this one? Can we remove moment at A?
Can.
Can, right? So we have actually 2 types or 2 possibility. 2 possibility. We can have macam ni. So I remove roller, I remove support. I just put the free body diagram based on the support. Okay. So original kat atas ni. So original kat atas ni. Original kat atas ni 1, 2, 3, 4. Okay, we can have. Okay, yang atas tu indeterminate. 4 unknown reaction. 4 unknown reaction. When we remove moment at A, what we get? What we get? When we remove moment at A. So ni diagram number 1, ni diagram number 2, ni diagram number 3. When we remove moment at A, we get what we call simply betul tak ni?
Betul.
Okay. And number 3, diagram number 3, we remove BY, we get what we call this?
Cantilever.
Yes, it is cantilever. Cantilever beam. Cantilever beam. So if we have, okay, indeterminate structure in diagram 1, okay, where we have AY, AX, and MA, and then we have BY. Okay, diagram number 2 is simply supported beam. Whenever we remove MA from the beam. Okay, means that to get A, we actually removing MA. Sini kan redundant dia ni is MA. Okay, diagram number 2, which is actually simply supported beam, we get after we remove MA. So MA is the redundant. Okay, diagram number 3, redundant for this diagram is what? B Y. BY. So we have removed BY so that after removing BY we get cantilever beam. We get cantilever beam. So 2 and 3 ni is actually called as possible primary structure. 2 and 3 is actually called as this. There are 2 possibilities for one redundant. There are 2 possibilities for one redundant. We have number 2 whenever we remove MA. Okay, when we remove MA, it becomes simply supported beam. It is determinate and stable. Determinate and stable. Or if we remove BY, we get a cantilever beam. A cantilever beam, it is determinate beam and stable. Okay, these two diagram, okay, under itulah number 2 and number 3, these two diagrams are called as possible primary structure. Possible primary structure. Okay, possible primary structure. Siapa tak faham yang ni? Siapa yang tak faham yang ni? Semua faham ke?
Faham.
Okay. So the structure after removing redundant from the system is called as primary structure. We have 2 possible primary structure when a redundant is 1. We have 2 possible primary structure when redundant is 1. Whenever we want to remove redundant, we have to make sure that we will get determinate and stable structure like this. Okay, means that we cannot simply remove AX or AY. Boleh tak kalau kita just nak remove AY from the first diagram? We have AX, AY, MA, BY. Can we remove AY?
Tak boleh.
Tak boleh. Sebab apa tak boleh? Dia akan relate back dengan support punya karakteristik tadi. Remember support karakteristik? Bila kita nak buang satu from fix, yang kita boleh buang is what? You remember that?
Moment.
Yes. Bila dia fixed support, we want to remove one, we have to make sure that fixed support, when we remove one, dia jadi pin. And pin must have vertical and horizontal reaction. Means that we have to remove moment. We cannot simply remove AX, we cannot simply remove AY. So bila fix nak remove, mesti jadikan dia pin. So nak jadikan dia pin, kena remove moment. Faham?
Faham.
Is it okay?
Okay.
Okay, clear tu? So we can have two possible primary structure because we can have two possible redundant. Means that whenever we want to solve problem, for example, we want to solve for the reaction for diagram number 1 for unknown reaction. We will only consider one possibility. Kita tak payah buat dua dengan tiga tu. So we just choose one. We can solve or we can analyze the indeterminate beam given, okay, by choosing MA as redundant or by choosing BY as redundant. So at any time kita just choose one. Okay, at any time we just choose one. Kalau kita dah pilih moment as redundant, so kita analyse lah primary and redundant structure tu as simply supported beam. Kalau kita pilih nak remove BY, so kita akan analyse primary structure and redundant structure as cantilever beam. Faham? Okay, so analisis dia akan analisis biasa-biasa yang pernah buat before this. Dia sangat biasa-biasa sebab kalau you belajar beam, topik beam, you akan belajar beam yang pelik-pelik. For example, loading yang pelik-pelik, kan? Loading yang sengit lah, kan? Betul tak? Lepas tu ada internal hinge lah kat tengah-tengah. Lepas tu ada support yang ada degree lah, dia ada certain angle. Betul tak? Betul tak yang tu yang you belajar dulu?
Betul.
Tapi whenever you want to analyze this, actually dia akan jadi beam yang simple-simple. Just simply supported beam, cantilever beam with loading pun yang point load or macam ni lah, UDL yang simple-simple. So kita tak bagilah yang loading yang pelik-pelik yang macam ada tiba-tiba ada internal hinge, tiba-tiba ada loading yang triangular pun jarang-jarang. Mungkin ada tapi jarang-jarang. Tapi yang very common when you need to analyze indeterminate structure ni, basically you will have UDL or point load macam ni. Point load yang simple-simple. Bukan macam ni lah kan, yang ni UDL. Okay, so both primary structure and redundant structure tu, dia akan follow either one. Either one. Means that kalau moment as redundant, primary structure and redundant structure tu dua-dua jadi simply supported beam. Yang ini. Primary structure dengan redundant structure ni, primary structure and redundant structure, dua-dua tu determinate beam. Dua-dua tu stable. So kalaulah moment yang you pilih as redundant, so bila pilih moment as redundant, structure tu dia jadi simply supported beam. So primary structure pun simply supported beam, redundant structure pun simply supported beam. Okay, so if you remove BY as redundant, primary structure become cantilever beam, redundant structure become cantilever beam. Okay, that's the idea. Tapi between primary structure and redundant structure, of course, it will be differ due to the loading. Because redundant structure ni tak ada loading. Tak ada external loading. Dia ada redundant, dia ada and applied we will put moment and BY tu, we will put back the redundant as a unit value dalam redundant structure. Dia mirip-mirip kepada virtual work method where the real system you analyze real structure, the virtual system you analyze the structure subjected to a unit value. So in flexibility method, the difference between primary structure and redundant structure, similarity dia both are determinate structure. Similarity dia. Difference dia, primary structure is actually determinate structure subjected to external loading. Redundant structure is a determinate structure subjected to a unit value. Tapi ada tambahan belakang, a unit value of redundant. Kalau dulu a unit value. Virtual load tu is a unit value. But redundant structure is a unit value of redundant. Okay. And then compatibility equation we will get whenever we analyze displacement for primary structure and for redundant structure. For primary structure and for redundant structure. So ni konsep-konsep yang you kena faham. InsyaAllah nanti kalau you try to understand whatever I have explained to you, InsyaAllah bila buat example nanti you akan get clearer picture. InsyaAllah. Okay, so this is the compatibility equation. So yang ni dah sebut tadi, P dengan delta, M dengan theta. Okay, so yang ni saya akan buat satu video and nanti tengoklah bila-bila you free before next week. Please tengok macam mana saya akan analyze this simple beam one single span, okay, to determine the reaction at A and at B. Okay, so now do you have any question? Do you have any question?
Tak ada.
Nope.
Okay, so nanti tengok balik. Actually kan, I have uploaded previous semester, bukan semester lepas je, semester sebelum ni pun dah ada banyak video dalam my YouTube channel. Ada yang saya bagi dalam group tu kan, channel nama saya tu. Okay, you boleh tengok lah kalau you nak tengok yang tu. Tapi saya akan buat another video jugalah untuk tunjuk balik how we analyze this. So dia akan apply balik all that I have said to you, okay, along these 2 hours lah. Okay, so try to faham konsep dulu. Because bila you dah faham konsep tu, analisis ni dia akan, because flexibility method ni dia konsep. Analysis dia is analysis of reaction, analysis of internal forces. Kalau beam moment equation lah, writing moment equation. Lepas tu kira displacement. So tiga-tiga yang output yang saya mention tadi. So kalau you ada strong basic in calculating reaction, in writing moment equation for beam, lepas tu you can be able to solve displacement. Okay, displacement ni yang kita buat integration. Tapi bukan integration guna calculator lah. Bukan integration using manual lah. Bukan you kena tulis balik. Lepas integrate, lepas tu kembang jadi apa, tak payahlah kan. So what you need to do is, you dah dapat equation, you terus use calculator, integrate and just give the value. Sebab kita nak that displacement. So displacement in primary system, displacement in redundant system, we substitute into the compatibility equation. So sampai dapat compatibility equation tu, kita dah boleh solve redundant. Dah dapat redundant, dah boleh solve remaining reaction. So idea dia yang tu. So nanti saya akan tunjuk, okay, this example, full example, how we want to analyze this in order to calculate reaction. Okay, so kalau nak sambung lagi pun takkan boleh habis dalam 10 minit ni. So I will stop right now. But before I stop, you dah tanda dah you future tu?
Dah.
Dah. Okay, nanti saya everyone tanda . Okay, sekejap yang ni saya nak tutup dulu. Okay, and kita kejap, saya tutup spotlight. Okay, so sebenarnya for me, every time end of class, I want to have photo session. So I want everyone, okay, to on your camera for the photo. session. Boleh? Sekejap. Okay, please on your camera. Okay, lagi. Sekejap. Okay. Check any announcement dekat Teams class ya. Dekat group or dekat general post tu lah. Okay, I'll be using Teams for conversation as well. Kalau you have any question, you nak tanya saya, so I prefer kalau boleh tanya je dekat group tu, dekat general post ataupun tanya direct dekat group yang private group yang saya dah create ikut registration list tu. Boleh tanya dekat situ. Okay, kalau segan sangat tanya personal bolehlah dekat Teams chat. Tapi saya lagi prefer you tanya dekat dalam Teams. Mana-manalah dalam group or dekat general. Dekat mana-mana channel lah, mana-mana channel saya akan respon. Okay. Ada lagi yang can on camera? Okay. Siapa tu yang nampak kepala je tu duduk betulkan diri. Okay. Ada kelas lepas ni? Do you have class after this? Do you have class?
No.
Oh.
Oh, tak ada kelas dah. Okey, saya kat belakang. Baju belang sebelah saya siapa nama? Siapa nama baju belang belakang sebelah saya tu? Nama siapa?
Syamimi.
Syamimi. Okey, satu lagi? Seorang lagi? Tak dengar?
Saya Zatul.
Oh, Zatul. Okey, Zatul. Sebelah Zatul siapa nama?
Fauzan doktor.
Fauzan. Okey, line nombor 2 dari belakang. Okey, baju putih. Siapa nama? What's your name? Nampak kan? Everyone nampak kan screen kan? Aiman. Okey, sebelah. What's your name? Baju putih Aiman ya? Okey, sebelah Aiman siapa? Tak dengar? Siapa nama yang sebelah Aiman tu?
Safwan.
Okey, Safwan. Okey, sebelah Safwan?
Ayub.
Ayub. Okey, sebelah Safwan Ayub. Sebelah Ayub?
Faiza.
Faiza. Okey, sebelah Faiza?
Putri.
Putri. Okey, di depan Putri.
Tasnim.
Tasnim. Sebelah Tasnim?
Aidil.
Haidil ke Aidil?
Aidil. Selamat Hari Raya Aidilfitri.
Oh, Aidil. Okey, Aidil. Okey, tepi Aidil?
Graris.
Zaris.
Jaris.
Oh,
Jaris.
oh Jaris. Okey okey. Depan Jaris.
Zikril.
Zikril. Okey, sebelah Zikril.
Aminah.
Siapa nama?
Aminah.
Aminah. Okey, Aminah. Sebelah Aminah.
Akmal.
Akmal. Okey, lagi. Sebelah Akmal siapa? Jangan off lagi ya, belum ambil gambar lagi. Siapa nama? Cepat. Tak dengar. Okey, tak apa, tak dengar. Depan siapa nama depan? Baju merah
Rifki.
Rifki. Okey, sebelah Rifki siapa?
Akilah.
Akilah. Okey, tepi Akilah.
Farha.
Farha. Okey, tepi Farha. Tepi Farha. Siapa nama tepi Farha?
Armin.
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 Okey, depan Armin. Depan sekali. Baju hitam. Ya? Naim. Naim Amirul Naim. Okey, tepi Amirul Naim.
Balkis.
Okey, Balkis. Okey, tepi Balkis. Azatul. Okey, so kita take photo. Okay, everybody smile. Izatul tadi mana? Nampak kucing je tu. Okay, ready 1, 2, 3. Kejap. 1, 2, 3. Kejap. Hang pula. Kejap. Okay. Okay, one more. Sekejap saya nak paste dulu. Kejap. Mana pula pergi conversation ni? Okey, lagi sekali. Okey, 1, 2. Sekejap. Okey, one more time. 1, 2, 3. Okey, sekejap. Mak. Sekejap, termasuk yang tu pula. Sekejap Okey, 1, 2, 3. Okay, sekali lagi. Hang pula lepas 2 jam kejap Okay, sekali lagi tengok kamera. Setelah print screen tengok. Okay, 1, 2, 3. Paste pun tak boleh ni. Paste. Okay, baru ada. Okay, okay, last one. Okay, 1, 2, 3. Okay. Okay. So thank you very much. We close our session today with Tasbih Kifara and Surah Wal As. Okay, insyaAllah we will meet again in the next session next week insyaAllah. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Thank you, Doktor.
Thank you,
Doctor.
Doctor.
Thank you,
Thank you,
Doctor.
Doktor.
Okay.